Welcome, everyone. Welcome, everyone. Yes, I'm just checking my microphone here. Welcome, everyone. Now I can see that the speakers are on. Pleasure to see you all today. I'm Marc Godin. I work with PTAC, Petroleum Technology Alliance Canada, and I'm also co-lead of the CRIN Methane theme area. CRIN is the Clean Resource Innovation Network. Before any further part of the proceeding, I want to read the land acknowledgement. Acknowledgement of the land is an important step toward reconciliation. In the spirit of reconciliation, we acknowledge that we live, work, and play on the traditional territories of the Blackfoot Confederacy, including the Siksika, the Kainai, the Piikani, and the Treaty 7 tribes comprised of the Tsuut'ina and the Stoney Nakoda nations, as well as the Métis Nation, Region 3, and all the people who make their homes in southern Alberta. CRIN is a network nationwide from Newfoundland and Labrador all the way to British Columbia, and we welcome you. We have an audience here in person in Calgary, but I am sure that we have people logging online and viewing this webinar from all parts of the country. Today we're pleased to highlight and provide an update on 3 important projects that are part of the methane emissions reduction theme area of CRIN. But before I introduce our speakers and move forward to the presentation, I have a few housekeeping notes here. So as you know, we are using the Zoom webinar platform, and those of you here who are in person, please do not join the platform as well as being online, because that will create echoes and feedback onto the audio. If you wish to ask a question, we encourage you to ask a question. For those in person, when we get to the Q&A after the 3 presentations, please just raise your hands and wait for a microphone to be brought to you. It's not that you cannot speak loud enough for me to hear you, but it's because we need a microphone for the people online to hear you. And then, when you ask a question, please state your name and affiliation. For people online, please use the question and answer feature of the Zoom platform at the bottom of your screen. Include your name and affiliation and the question you wish to ask. We have CRIN staff here monitoring the Q&A module in the Zoom webinar platform, and they will ask that question on your behalf. So as I said, we are highlighting 3 important projects, and I will introduce each speaker in turn. So first up is a project entitled Simple Methane Elimination Using Nitrogen, and it will be presented by Jacqueline Peterson of Cateros Solutions. Jacqueline is the Director, Policy and Offsets at Cateros Solutions, a Canadian company providing critical emission reduction technologies to North America's oil and gas industry. She oversees Cateros' emissions offset program and brings over 10 years of experience in research, design, policy analysis, and project management to the role. She completed her PhD from the University of Toronto, where her research focused on sustainable infrastructure, environmental management, and climate finance in Canada and the United States. Help me welcome Jacqueline to the microphone.
Great, thanks, Mark. All right, it's great to be here today. Thanks for coming out. Thank you, CRIN, for hosting us. So I think today we're really all just going to be giving a very brief overview of our projects, where they're currently at, and then hopefully we have some time in the Q&A to kind of do more deep dives into particular topics. So just over a year ago, we were awarded funding from CRIN for a commercial demonstration of our technology. Sorry, just bear with me a minute while I figure out the clicker. Okay, there we go. I'll just skip through over there. So our technology tackles this question of methane venting from pneumatics, which is a significant source of emissions from the oil and gas industry. We take a bit of a different approach to this problem. Instead of trying to bring electricity to a site, or install, solar panels, generators, that kind of thing, we actually just replace the gas that's being used to drive pneumatics. So instead of relying on methane or natural gas to pressure and drive these pneumatic pumps, controllers, we use nitrogen instead. So we'll put a tank like this on the site, we tie it into the existing pneumatic systems, and then the nitrogen, which is stored in liquid form, gets converted to gas once it hits everyday temperatures, and it's dispensed at the quantities, pressures needed to drive your pneumatics. But instead of venting methane in the process, nitrogen gets vented instead, and it's a clean, inert gas, just goes back to the atmosphere that it came from. So this technology is a bit different than others in that it involves what we call a nitrogen distribution network. So similar to a propane model, once these tanks deplete, we have to go around and refill them. Also similar, I guess, to a propane model, it's really not economic to just service one tank here and another tank 400 kilometers away, right? You need to have kind of those economies of scale in order to be able to provide nitrogen really cheaply to your customers and make it a really cost-effective, affordable solution. So what this project, it wasn't testing out the technology itself, it was testing out the improving the commercial viability of the project. So involved in this was, we actually started with 40 sites that we were going to put these tanks on, in partnership with both with Synovus, and then Ovintiv wanted to join as well, and we increased the number of sites to 70. They're all operating in the Grand Prairie region. But with this number of sites, we then have those economies of scale to provide economic nitrogen distribution around the region, around the province. So that's really kind of the gist of the project. When we think about where we're at today, there's a bit of a typo here. So we have 42 tanks currently installed on 32 sites, and the remaining 38 sites are going to be installed in June. So this has been happening since March, but really the bulk of these tanks really just were installed over the last couple months. These range from single well pads to large 22 well pads is our largest that we're currently servicing. Everything's worked flawlessly, no incidents. And yeah, by having these initial 32 and growing to 70 sites in the field, we are now, we have achieved our objective of being able to provide nitrogen economically to our customers. It was our initial hope when we started this project that by the end of the project in March 2024, we'd be fully commercial, but we're fully commercial now and have customers now across the region joining on that are now able to benefit from these lower nitrogen prices, as well as just the technology in general. And so to date, even though most of these tanks only came online the last few months, we can already say that we've eliminated 7,000 tons of CO2 equivalent directly associated to this project. And of course, that will triple, if not quadruple, by the end of the project, but is really just setting the stage for significant emissions reductions moving forward across the industry. So we were asked to, speak to the good, the bad experiences we've had through this project, the various struggles. Lots of good experiences, things pretty much went as we hoped they would. We've also had really great support from CRIN, of course, as well as our partners at Ovintiv and Synovus. It's just been really great to see them get behind it and really buy into the technology. So that's been great. The bad, not really too much to say. I think there were some administrative hiccups as we just started getting going back last year, but that's all been ironed out. Everything's working great now in terms of just navigating these relationships with other, organizations and whatnot. The ugly, this is really not even related to this project at all. It's just kind of an ongoing frustration I have, which is just kind of the lack of regulatory certainty we have right now in Canada regarding pneumatics. This is compared to the US, where there are very strong regulations, very specific, very detailed, and we're really seeing our sales at least really skyrocket in the US. And while things are growing here, I think that is the one really major difference. Yeah, collaboration opportunities. We're always happy to trial our systems on, for anyone. You don't like it, we'll just take one of our tanks off, and it's pretty easy, pretty simple process. I'm also always loving to chat, not just about our technology, but about Alberta, Canada's clean tech ecosystem, which I think is just a really exciting place to be here right now. And then finally, next steps. So 38 more sites still to do, scheduled for June. And then obviously we're gonna just keep an eye on them, make sure that everything continues to work as they have been working, see if there's any ways to optimize the performance or the operations. We do provide emissions reporting every month to our customers. We're also just serializing our first round of offsets as well, which have been independently verified for 2022, and continuing to build our outreach and growth in Canada. So that's kind of where we're at in a nutshell, but happy to chat further after this and after this event as well. Thanks.
Thank you, Jacqueline. I remember we hosted a webinar during the pandemic for Kateros, and it's wonderful to see the growth, and thank you for CRIN for enabling that growth. At the time, you were just looking for the first site, right? So now it's great to see moving on to double-digit numbers. The next presentation is a cost-effective and accurate end-to-end multi-sensor digital platform for methane detection, quantification, monitoring, reporting, and prediction. And it will be presented by Steve Liang of SensorUp. Dr. Steve Liang completed a Bachelor of Science in Surveying Engineering at National Cheng Chung University in Taiwan in 1999, and earned his doctorate in Earth Space Science at York University in Toronto in 2007. He is currently an associate professor at the University of Calgary and the director of the Geosensor Web Laboratory. In 2013, he was chosen as one of Calgary's top 40 under 40 by Avenue magazine. Dr. Liang has been an invited speaker at universities and industries in 11 countries and held the AITF Microsoft Industry Research Chair on the Open Sensor Web from 2011 to 2014. I'm pleased to welcome Steve Liang to the podium.
Thank you, Mark, and thanks to CRIN to have this opportunity to present you what we have been doing, and a lot of things exciting happening in the company. And I would say CRIN Project is a key enabler for us to, progress, advance our company. Next slide, please. Oh, here. Thank you. I'm technically handicapped. Can you please make it full screen? And then I should click. Which one should I click? Which button? Got it. Thank you. Sorry, I'm dumb. What problem we try to solve here is we know we need to reduce methane emissions. We know there are many different new sensors coming up. We know there are many new different protocols, how to use these different sensors. We know we still need to send people there to confirm the leak. We know all the records need to be defensible so we can go through the audit. And eventually, we want to quantify all the emissions, okay? And however, all the sensors, they never agree with each other. They are just different resolution, different scale. And then we also know we hate false positives. That meaning if a sensor shout out loud, it's like, oh, alarm, leak. And then you send there, how many times you send a person there, you find no leak. So it's really a difficult problem, and many different data sources, they do not agree with each other, but we need that visibility, we need that truth, we need to quantify. And today, how do we solve that problem? Of course, Microsoft Excel. Right? So as a result, we see opportunity to really operationalize this with a cloud software as a data fabric, put everything together, including disparate sensors, prediction models, operational data, field operations for real-time emissions measurement, reporting, verification, and repair. So it's MRV, but R is very important too, repair, because if we repair early, we can reduce emissions. If we just keep it, just quantify it, it doesn't do anything good to the world. And our solution is a cloud solution. We are not a sensor company. We are not developing new sensor in this project or in our company. We want to be everybody's friend. We want to operationalize this as a data fabric and work with the different players there. So our solution has different parts. One is mission control. It's a desktop experience, a cloud software for emission engineers to operate as an operating system to operate this. And with Outpost, which is our mobile phone, and then let the field workers to go there to do inspection, repair, safety check-in, get the real-time data comes in, asset inventory, so on and so forth. But the key ingredients or secret sauce is called Data Foundry. It connects different data sources, clean them, aggregate them, fuse them, present them, and to the relevant users in using Mission Control or Outpost, so that we can operationalize that. Next slide, please. Okay, progress to date. We are actively developing our Sensor Emission Management Suite called EMS. We like the acronym. And then right now, the software is deployed to more than 4,000 sites in Canada. And then system will, the new system will go online in June or July 2023. And then thanks to CRIN support, we are launching 2 major projects in Houston area, not Houston area, in United States, 2 Houston-based companies. It is very, very major for us. And then we're launching a platform with a major customer in November 2023 at a major United Nations event. And to, please pay attention to press release, and then we're gonna announce some press release news in June. Next slide. So challenges, so lesson learned. So one thing is, I think one of the key issues for this is the protocols, standards, and the science is evolving very, very fast. So again, no code reconfigurability is necessary as the standard, the protocols are changing very, very fast. So this flexibility is very important because, as it evolves every year, you don't want to hire, have the team. You say, okay, let me work on a year so we can update the next version for the next version of the standards or protocols or the science. No, it need to be updated like all the time. However, all the updates need to be recorded and defensible, can be auditable, right? And the following protocols and industry best practice is very critical. Again, it's because it's evolving very, very fast. And we want to do a best job, right? And building such system require oil and gas expertise. So that meaning when we hire, it was like, we need oil and gas expertise, we need methane emissions knowledge, and we need a team, asking team to develop cloud software and put them all together into one person. I don't know where to find that person. So actually talent is a key challenge here. But fortunately, actually in Calgary, we are able to find this kind of talent together, right? So it's a good place to find that, actually. And challenges, very fast evolving market, a lot of noises in the market. Everybody, sorry, my joke is every bozo try to do this data fabric and put it all together, right? And I'm one of them. So it's a lot of noises in the market, and then I think our customers, that's a challenge for them as well. And many different sensors at different spatial temporal scale. So another joke is a lot of people try to develop new sensors. It's a great thing. However, also created new noises, right? Because they need to be validated, they need to be proved, they need to be calibrated. And that's just, kind of noisy market right now. Okay, so next slide, please. So opportunity, if you would like to partner with us, either you are a technology provider, sensor maker, vendor, or you have a prediction model, or you're consulting agencies, and want to partner with us to deliver the solution to the market, please talk to me. That would be great. Thank you.
Thank you, Steve. And I think of Steve as perseverance. I mean, I remember, rainforest meetings and we're going to have, and we'll be there for the next few years as you keep going, that's for sure. Our next presenter is, title is 1 kilowatt electric gas wellhead remote power unit, and it will be presented by Martin Elfrink of Etelim. Martin has experience with bringing ideas from concept sketch to mid-volume manufacturing in both small and large organizations. He has over 12 years of experience as mechanical design engineer, system architect, project, product, program manager, and team lead of up to 15 people in the clean tech and printing industries. And Martin is not with us in person, but he'll join us through the wires behind this screen. And I'll just, I'm assuming you're online, and go ahead, Martin.
All right. I hope everyone can understand me or hear me. I also wanted to quickly, it's super weird to join this right now online because I have no clue who I'm speaking to. Can somebody at least let me know what kind of audience we're talking about, who is there and how many people, something like that? Gives me a little bit of an image
we have
to present.
about 20, 30 people in person here, and we have an equivalent number online. The numbers fluctuate, but you have a great audience of knowledgeable people who have a lot of experience in the methane space.
Excellent, very good. Thank you, thank you. It gives me an image to who I'm presenting to in this case. So, nevertheless, I'll start. Hi everyone, my name is Martin Elfrink, and I'm leading the Etelim team located in Burnaby, BC, and that's where I'm situated right now. We are a B2B company manufacturing a physical product, 1Gen, an ultra-reliable generator suitable for electrifying small to medium oil and gas well sites, enabling cost-effective methane venting elimination and reducing greenhouse gas emissions by over 98%. Thank you for the opportunity to present at this CRIN Project Cafe and the ability for us to provide an update on our project, 1 kilowatt gas wellhead remote power unit, which is a mouthful as a title itself. That is currently being executed with the support of our project partners, Spartan Controls, as you can see on my slides, CRIN and NGF. I think I can control it here. Yeah. Before we begin, I would also like to acknowledge that I'm presenting from the unceded traditional territories of the Musqueam, Squamish, and Tsleil-Waututh nations. I think that's something important to add to my presentation. So here at Etelim, we are bringing the ultra reliability and cost-effective advantages of thermoacoustic power to the world. We are a world leader in converting heat to electric power through thermoacoustic physics and have over 10 patents on our external heat engine, which you can see on my slide here. We have a path to 29% heat to power conversion efficiency, which is about 10 times better than thermoelectric generators, and have been awarded multiple clean tech awards over the last couple of years. We are excited to use the methane venting reduction efforts in the oil and gas industry as our beachhead market. As most of you guys already know, right, there are 130,000 gas wells in Western Canada that through venting of methane from pneumatic processing devices are responsible for 1% of all of Canada's greenhouse gas emissions. This is not only oil and gas sector. This is all the emissions that Canada is putting out there on an annual basis. This impact is recognized by the government, and regulations are being put in place to eliminate this, which means many well sites need to be converted to energize the processing devices differently. Many of these sites are located remotely, meaning that no grid power is available and or accessibility is challenging as well. So different solutions exist, as Jacqueline from Catharos was already mentioning as well, using the regular bleed pneumatic instrumentation as the baseline, because there's still instruments like this out there in the field that are venting like traditionally. Improvements can be made by switching to low bleed pneumatic controls, but this is only a partial solution. Capture and burn is also possible, but technically challenging and a waste of energy. Using nitrogen can eliminate emissions during the use phase, but it would still require cost and emissions of the supply chain. So that's something to keep in mind. The main solutions being implemented at the moment, based on our understanding, is electrification, with the big advantage of reducing site visits by being able to remotely tune your asset. On-site electrical power allows existing pneumatic instrumentation to be powered with compressed air or directly actuate electrical instrumentation. So there's different variations available there. Just to give us an overview of our current understanding of what is happening in the industry. So Our project, which we're doing with CRIN, which started also about a year ago, its objective is to package our existing thermoacoustic external heat engine and make it suitable for the Wellhead methane venting elimination application. We're performing an 8-month field test, which is starting later this summer. And all of this needs to happen within 24-month time frame with a total budget of about $1.5 million. Let me continue. Okay, so at ATLM, we developed a unique electrical generator here, which you can see on the screen, which we call 1Gen. A small amount of field gas that otherwise would have been vented is used to generate power and drive a compressor that energizes the existing devices with compressed air, reducing greenhouse gas emissions by over 98%. 1Gen can power up to 6 wellheads per unit, making it ideal for mid to small size well sites. So 1Gen will be able to deliver a peak power of approximately 2.4 kilowatts, while at continuous running consumes a field gas equivalent of about 2 low bleed instruments. We're designing for a 2-year maintenance interval, even though the core engine is expected to last well over 10 years without any maintenance. The complete unit is developed for -40 to 50 C or 55 C without the need for additional cold start packages. So that's what we're having as part of the core of our design directly. We are certifying under UL 2200, making 1Gen suitable for general purpose area. And we expect that 1Gen will be able to deliver a very attractive and cost-effective electrification solution for small to medium well sites. And that's what this project is about. We're going to prove that. Our thermoacoustic technology is what is behind all of this and allows for 1Gen to be an ultra low maintenance system, since it does not contain any sliding or rotating parts. The engine consists out of simple parts that have been inspired by automotive manufacturing techniques and that has been developed over the last couple of years. 1Gen is ultra reliable and the core engine is expected to last well over 10 years without any maintenance. Thermoacoustic technology allows for true load matching between 0 and 100%, meaning you never have to actually turn off our engine. We believe we can provide a unique cost-effective solution for this application based on our thermoacoustic knowledge and physics that is behind this. Even though not part of this project we discussed today, I would like to mention a couple 1Gen features that came out of customer interviews and are built into the 1Gen architecture from the get-go. Besides field gas, we will also be able to combust natural gas or propane. Configuring 1Gen in an array is also something which is important because it will enable customers to easily follow changing power demands over the lifetime of an asset. 1Gen can easily be redeployed at a different site and allows for modularization and unification of power generation equipment among assets. 1Gen has been prepared to use its waste heat to be utilized for external glycol heat tracing as well. 1Gen is also expected to be a great fit for solar hybrid systems. We expect that due to the true load matching capability, solar hybrid systems can be made more cost effective due to reduction of solar array and battery bank sizing, often designed for corner case situations. We believe that these features make 1Gen future-proof. Nevertheless, let's get further to the actual project we're going to talk about instead of just a sales pitch. The current project contains 4 stages. So there's design, build, certification, and the field test. We have successfully completed the specification, design, and build stages and are currently making good progress in the test and certification stage. So regarding challenges and lessons learned, I gathered a couple key items from our project so far. So first, a challenge at the start of this project is that at ATLM, we did not have detailed application knowledge. So we're learning as we're going. I was also at the PTech conference, learned a lot, and we're trying to keep this communication open to keep learning all the way. So by going out in the field at the beginning of this project with our partner, Spartan Controls, we learned a lot, just going to the field, understanding what this application looks like and where this device actually ends up with. So that's a picture which you can see, I don't know, on your right hand side of your screen. And that was very helpful. Regarding supply chain challenges, at the start, we encountered the challenges due to COVID-19 and currently are also experiencing the effects of the inflation, right? So which is not necessarily adjusted in our project budget. So that's where we have to be creative. And we are using, for example, some legacy parts from previous projects in order to be able to push this project further ahead. We did also early ordering of parts in order to have them available in time because the lead times have been really long on a lot of parts. Verification of specifications is also something which is still work in progress. However, we started very early with sub-assembly testing to get good indications if we're going in the right direction. And a good example is that our burner test bench, where we were fine-tuning the burner and the fuel train. The project timeline allows for very limited number of design iterations. So we try to keep our design as simple as possible and design it modular, so it's possible to upgrade sub-assemblies as we go without holding up the project. So another thing is items that are today's challenges and are work in progress and that we're certifying is related that we're trying to certify a new technology to existing standards that are not always applicable. For example, UL 2200 is a generator certification, but is designed for internal combustion engines and gas turbines, which all contain sliding and rotating parts, which we don't have any of. So this requires a lot of discussion with the certification body and is still a gray area. While we have a good path forward right now, it is always something that on a time scale is an uncertainty and a risk. Then another challenge that we have is that we're trying to balance exposure of our products with testing partner testing grounds. So how much do you want to expose of what you're doing versus how much do you want to go to partner testing grounds with partners? And we think it's very important to work with partners because we want to fine tune and improve the product over time. So direct feedback is important and a transparent working relationship is also very important. Nevertheless, okay, regarding collaboration opportunities, I thought about this a little bit, or we thought about this a little bit and put a couple items together. We strive to be in close communication with potential customers to help us with product tuning, as I already mentioned, and make sure that we're actually solving a problem of theirs. Even though we're expecting to use the NGF Emission Testing Center for future testing, as a company, we want to solve a real-life problem in the field as soon as possible, because this is creating credibility for us as well. So we're trying to mix and match that as well. Another opportunity to work together. While we still learn every day about this application, we notice that well site power requirements is a complex matter and something that is not always that well understood in order to get a cost-effective methane elimination of the industry as soon as possible. I think there's a great opportunity to share applied knowledge on optimized well site electrification among producers and equipment suppliers. And I think that is something that everybody could benefit from, and all the speakers here even could benefit from. So I don't have a solution for that, but maybe CRIN can help with that as well, to think about how we can improve on that. Another item which I would like to highlight is that life cycle analysis is a great tool to stay ahead of regulations. It helps to get an overview of emissions during the manufacturing, use, and end of life phases, so all phases of a product, right? And properly compare to how future-proof solutions really are. So let's not only focus on the use phase or not only on the manufacturing phase, but look at the complete picture in order to see what's the best solution on the long term for your company. Last but not least, any help that can be given regarding funding will of course help accelerate the availability of our product, which we believe is a direct, high-impact climate solution. Okay, our next steps are continuing with internal testing and upgrades, certification as mentioned, and it will be followed by the installation at a field test site. At the end of the summer, we expect to also be able to show our product to potential customers and receive additional feedback outside of our current partner group. If you have any questions, suggestions, or other feedback, you can find our contact information on our website, and please reach out. Okay, a quick recap of what I just did. OneGen offers ultra-reliable off-grid power suitable for electrification of small to medium gas well sites. We offer a direct high-impact climate solution, and we have a partnership in place with Spartan Controls and are experiencing actually market pull regarding our product, and that's a really positive sign for us. Our engine has been built and tested for over 12,000 hours, and we're working towards a field test this summer. We expect first deliveries of the OneGen units around Q2 2024. And I would like to thank you for your attention. That's the end of my presentation, and I'm looking forward to what kind of questions you guys have for me. Okay, thank you.
Thank you, Martin. I'd like to move to the question and answer part of this event. We'll put a couple chairs here for Steve and Jacqueline, and Martin will be online also. So we'll have 3 panelists. I hope that you have been, people in the audience here and online, thinking furiously about what questions that would be insightful question. What do you like to know more? What do you think about the future for our panelists? We're looking also for the folks online to ask questions. So I'll start with the audience here. I see one in the back, and maybe we'll bring a microphone to you. And Go for it.
Party nitrogen, or are you putting a membrane system in place in the area that you're supplying the nitrogen?
Yeah, great question. This is on. So when we very first, shout out to Mark here in PTAC, because it was through PTAC, Ken Eric funding, that we did do our initial field test, like one site, and that we did get third-party nitrogen. But really the purpose of this project was to make sure that we could have our own fleet of trucks that are able to service this. And this is actually our founders. They have a long experience in the cryogenic oil and gas services, and only recently now have come to this recognize this environmental application of it. So we do have a really long experience working with nitrogen, transporting it, being able to transport it in liquid form, and yeah, and manage, oversee it.
That was my other question. Everything's stored in liquid form, then turned gaseous as it goes to atmospheric pressure, obviously, or
Yeah.
yes. Without the localization, have you done the ROI on instrument air versus nitrogen?
Yeah, I mean, we have, and I mean, I could go on, I guess, forever. You know, so much is contingent, the size of the well site and whatnot. But one thing, I think that initially we thought, you know, we're really going to be tackling these like small to medium well sites, because the nice thing about the system is you only really pay for what you otherwise would have vented, because the main cost is nitrogen. So it's pretty cost effective even for those low vent well sites. But we started to see that more and more of our customers want to try it out on some of their bigger applications, just given the reliability of the system. There's no need for power. It just works on thermodynamics. Like, it's just a very simple piece of technology. We actually see them around the world, like outside of hospitals, and this is just the first time it's been used in this way in oil and gas.
Last question for you. Is it accepted by greenhouse gas protocols to get offset credits?
It is, yeah. We're just in the process right now of serializing. The verifier signed off on it. The registry has it. And I'm also excited to say that the next protocol that's currently being finalized with AEPA, I guess, does have nitrogen in it. So it's like, we don't just need to get deviation requests anymore. It's now formally accepted. So that's really exciting.
And then Martin, how clean does the fuel have to be used in your system?
Sorry, can you hear me? I'm not sure. I'm being unmuted and muted every time. So that is something that, of course, needs to be proven, right? So we have an external heat engine similar to Stirling engines on the market. So we expect a similar type of performance. We, of course, will start with this project because there's a new product coming into the market with the easier field gas sites, right? And we'll ramp up, of course, to when there's more H2S in it and that kind of stuff in order to see what the limitations are of our engine. We are using a very highly corrosive resistance material in our external burner, so we expect that we can actually do very well in that regard. Is that answering your question?
Oh, thank you, Martin. Well, I do have a question for you, Martin. Just curiosity. The word acoustic in your design, where does it come from? How do you have sound waves creating power?
So what actually happens, I'll try to explain it as simple as I can. So what happens is that by creating a temperature difference, which the hot side is because of burning some of the field gas and the cold side is because of a radiator system, right? You can create acoustic waves in a medium, which is helium in this case, also very similar to the Stirling engine. That those acoustic waves can be harvested not with a piston, which is like the second generation Stirling engine. We are more like a third generation Stirling engine, where we use a thick steel plate that is actually vibrating, and we can harvest that mechanical power through a linear alternator.
Awesome. Thank you for the explanation.
Yeah. We have a question online for Martin. From an LCA perspective, any insights you can share regarding the full cycle carbon payout?
Yes, so I'm a little bit preaching here life cycle analysis, but we haven't gotten to that yet. I do think it's a very important tool, and we will look at that as well more thoroughly to do a life cycle analysis. At this point, we're finalizing design, right? And at that point, we can do that life cycle analysis properly to make a better claim one way or the other. Yeah.
And
So
one,
sorry, maybe one addition to that, just to be clear as well. So we are a much smaller unit than some of the generators that are on the market, except of thermoelectric, which is of course also a much lower category. And so you can already look at weights and material use as an indication of what the manufacturing carbon footprint, for example, would be. Instead of only looking at the use phase, which is a little bit easier by just looking at the specifications. Yeah.
Thank you. Another question for you online. Any thoughts on reshoring or onshoring the supply chain to North America for specifically positioning your tech to the U.S. with respect to IRA production incentives tax?
I have not looked into that. I have to admit. I just want to say our current supply chain is almost 100% North America. Obviously, when we're getting to higher volumes, cost is driving for many people, and I don't necessarily know yet where that is going in terms of where the supply chain would go back to Asia, yes or no. At this point, everything is North America.
Great, thank you.
Thank you very much, Stephanie, for the online questions. Any other questions here? Yes, please go ahead.
Thank you. Question for Jacqueline. Two questions, actually. One, what sort of drawdown time are you guys seeing, like, let's say on a single well battery? Like, how often do you actually have to, are you estimating you're going to have to refill the tank? And I'll ask my second one after.
Yeah, so we have 7 different tank sizes. The smallest one's about the size of a, keg or hot water heater. The biggest is 5,500 liters. It's quite large, designed for, multi-well pads. We try to size them, so we refill them about once a month. But the one thing that's nice about it too is that we recognize that activity fluctuates over the course of a year and over the course of a well site. So you don't necessarily need to size the unit for its its maximum usage. You can, if it's in winter and the pumps are running much more frequently, then we might be refilling every 3 weeks, and then in the summer going longer than a month. And same with a number of our customers also now have us on their greenfield sites where you'll see really high activity at the beginning, and so we might be refilling there every week, but then after it kind of normalizes or what have you a few months in, then it's just every month. So that's one nice aspect of it. But we can always, if we do estimate what we think the tank is going to be, and then it actually turns out that we are refueling quite a bit, then we'll swap it out for a different size tank. It's pretty easy to do.
And number two, just now you're introducing a different product, I guess, out at the field level.
Yeah.
Any sort of safety or spacing issues, or has that come up at all as far from that process?
Yeah, I think we hear that concern a lot because it is new, right? And people recognize that it is ultimately a different chemical, right? Or gas that they're now working with. But it is very safe, and we just have all the operators mostly just follow the existing protocols that they have in place. So because methane or natural gas is also, toxic and a displacement of oxygen and these sorts of things. So as long as the same protocols are being followed, then that's all that's, required, and we haven't had any issues on the safety front. But of course, we treat it very seriously, and as you have to.
Other questions? While you think of it, I'll just follow up on one question with Jacqueline here. Maybe you could elaborate. There was a question of how to compare with instrument air, and more around the business model. I mean, instrument air is you pay up front and then the air is free. And in your case, it's more you don't pay much up front, but then there's a service. So maybe
yeah, we have no upfront capital costs. It's just an ongoing monthly fee for the tank rental, and then however much nitrogen you use. So it is different than instrument air. I think lots of time we think about instrument air as a large, like, one upfront capital expense, but then there are more like maintenance and parts replacements and questions of theft and just other costs. I mean, one of our customers in the U.S., a large producer there, recently put some of our tanks on some well sites that were electrified, and did have air compressors on site, and they put our tanks there almost as backup because the grid in the U.S. can be pretty shaky, and for those maybe 4 days a year that the grid goes down, they can't stop production, or they get severely, like, penalized economically. And so we have tanks there that are just ready to go, and this has in fact happened where the grid goes down, and because it's inert nitrogen, it can easily just be switched on and off. And yeah, so the customer had no downtime, which of course is really valuable, but also tricky
Awesome.
to quantify.
Awesome. So kind of qualifies as a battery in some ways. Steve.
Yes, sir.
Yeah, so you invited people for collaboration. You're building this large platform. Just elaborate a bit on what type of conditions, or what are you looking for people to contact you, either the sensors or prediction engines, or as Jacqueline and Martin have, reduction technologies. How does that work?
Yeah, so we see a gap in the market, which is you need to interconnect the different systems and quantify the reductions as well as detections. And then so our business model is, we're not competing with, sensor makers, analytics models, or consulting agencies. We want to, because actually the market needs multiple providers. But however, the problem we try to address is the operational, how to operationalize this. So as a result, we want to work with our go-to-market is really indirect, go through partners, right? We want to make money together and to improve the world. So that's our go-to-market. So we're not here to compete or to be the one ring rule them all, right? We are more like, let's be a happy family kind of thing. I think we need the ecosystem. We strongly believe in ecosystem. And we're not here, we are here to enable the ecosystem rather than to create a proprietary ecosystem.
So how does that work for a third-party vendor of a sensor? Do they have to onboard into your platform and become I don't know what the word is, member of your platform?
There are basically two ways. Actually, again, everybody wants to be driven by the market, right? Yeah. So two ways is maybe the vendor is like your customer will tell you you should connect to Sensor Up because we're using Sensor Up as the fabric. Yeah, so that's one way to work together, right? The other way is, let's work together before your customer asks you, and we go together to meet the parents, right? It's like, hey, we're married, and can we serve you? So there are basically two ways. Of course, I think the partners, they prefer the first way, which is the customer tell them, we're joint customer, and it's basically market pool, right? But we start to see more and more momentum on this, like, seems this is a good way to go, and your go-to-market makes sense, and then we can make the pie bigger, and let's do something first, right? So these are the both ways. So I really appreciate, of course, from our perspective, if you come us early, you get discount, you get more things to discuss. When your customer tell you to do that, and then customer dictate.
And is there a value of marketplace in here? Like sensor A is used by a couple of producers, they go on your platform, and then 20 producers get to see sensor A, and maybe is that work that way, or is it just data and it's all buried in
we don't have that in the plan yet as a marketplace, because it costs a lot of money to create marketplace and to maintain that, and also some dynamics which are interesting. We want to be, for now, we want to create that ecosystem. But if the producers, they want to see that, right, again, market driven.
Okay, perfect. All right, enough for my questions. Anybody else online or And I've not checked time here, so how much more time do we have here? So we have 5 more minutes or so.
We do
So-
have one more question online.
Okay, perfect.
Okay, so can you talk a little bit about the maturity of the thermoacoustic technology and what its competitive advantage is over other electrification options? This one for Martin, of course.
Yeah, fair enough. So thermoacoustic technology exists already for quite a long time. Actually, it's very similar to thermoacoustic to the Stirling engine cycle. So the first generation Stirling engine was with a crankshaft. I don't know if some mechanical engineers remember that from putting it on their coffee cup or some physics project or that kind of stuff. So that had a rotating part in it, and it had a piston which was moving up and down. The second generation Stirling engine is actually what is available currently commercially through one of our competitors in a way. We're actually not competitors because we're much smaller in size. That is still having a piston that is moving up and down, but it doesn't have the crankshaft anymore, and it uses a linear alternator. And what we've done, we actually have taken away the high accuracy requirement for the piston and put it into a steel plate. So we're using similar cycles, and the thermoacoustics is also very well understood and very well studied by, for example, Los Alamos National Lab in the US. That's where our third generation Stirling engine, that's a different way of phrasing our thermoacoustic engine, is coming from. So I would say it's a very mature technology in that regard. We've also done 12,000 hours of running already with it without any issues, which is approximately 3 years, I believe, and that is actually in a backyard somewhere in Vancouver. So that's not completely representative of the oil and gas situation yet, and that's why this project is so important to make it suitable for the oil and gas industry. Sorry, the second part of your question was about competitive advantages, I believe. Is that correct?
Yes. Yes.
So we are about 10 times the better efficiency than thermoelectric generators, and about half the size of what the current free piston Stirling engines are that are on the market, which means that we think we have a very cost-effective solution for medium to small well sites. Yeah. Plus the modularization, of course, that we have, that if you need more power than just one unit, you can deploy 2 units or 3 units in an array form. And you could take away those units and redeploy them at a different assets if necessary, so that you can actually grow with the power demands of your asset.
And you probably have an advantage on maintenance as well.
So I would argue that we are on par with a free piston Stirling engine in terms of dealing with field gas, dealing with maintenance, dealing with ultra reliability, all that kind of stuff. I think a given towards our technology.
Perfect. Thank you. So we have a question here in the room.
So, Martin, you kind of somewhat answered the question already, but what's the upper side? Are you guys looking at a larger unit at all by chance? Or you're just going to focus on that 1 kilowatt kind of range, or that really low end?
The question is, what is low end, right? So it comes down a little bit. Can you hear me, by the way? I see that my screen is gone. Okay.
Yes,
Well site power requirements and what is required is very difficult. It's a complex topic. So what is necessary? It's very interesting that what I learned now, at small to medium well sites, you see that especially with solar battery as well, people are going to downscale very much. And the 1 kilowatt is actually quite a bit of power for those sites. But if you look at the bigger multi-watt well sites, it doesn't scale with the amount of wellheads, for example. And I'm learning as I go, and please educate me in that sense, but it doesn't totally make sense yet with how people are mapping what power requirements are required for certain applications. So I think if we're the small 1 kilowatt site, yes, we're focusing on the 1 kilowatt continuous power at this point with 2.4 kilowatt peak power. That's what we're focusing on. One last remark on well site sizing and what power requirements you require. I think every well site is unique, and we need to have that conversation with the customer in this case in order to see what is required. Very important is the discussion about peak power requirements versus what is actually continuous power requirements, and that is something that if you have a battery bank system or you have a nitrogen system like Jacqueline's, where you also have a buffer of amount of energy, right? So that you don't necessarily, that you can peak shave your power requirements at that site. I think that's a very important discussion to have, so you can size your buffer as good as possible.
Another question online for Jacqueline. Are you using a third party to fill your tanks, or does Catharis do its own sourcing?
We chatted about this, I think, a bit earlier, but yes, we do it all. We have our own trucks, but I should just also mention that because nitrogen has been used quite a bit in the oil and gas industry for other applications, there's generally always nitrogen plants wherever there's oil and gas. So we never really have a question about supply, and if more nitrogen's needed, I mean, the main air or feedstock is air, right? So it's fairly easy to make and source. But yes, we provide that all ourselves, we distribute it, and that's all included in the cost.
One last question, this one from Martin. Could your generator be used with solar thermal loads?
Solar thermal loads. Okay, I'm trying to understand a little bit where this is coming from. Can you elaborate a little bit
Yeah,
more?
I would think it's be like a magnifying glass concentrating solar to your heat source.
Yeah, so
For
it is
example.
something that has been tested in the past, not specifically on our engine, but you have seen also free piston Stirling engines being used for a big ball with concentrated or a big ball with mirrors that are concentrating its sunlight on one single source, which could be the hot side of an external heat engine. So that is something that actually the founder of this company, which I'm not, has started, and the reason that he started on this on this journey. Is that what you mean with solar loading?
Yeah, we think so.
Okay.
And so to come back to the question, so that was ideas at the beginning, but presently that's not your focus. Is that-
Correct. So as a company, we're focused on this as a beachhead market, but our technology has potential for many more applications, such as we can run it in reverse and actually create a heat pump. We can do other kinds of items as well in other applications, which doesn't have our focus currently. We're really trying to focus on this market and trying to get to prove that our product can add a lot of value.
Perfect. So we'll do last call for any last question that tickle your brain. I think we're good. So thank you very much to our fantastic audience in person and online. Thank you for our presenters and panelists. And thank you for the CRIN staff for hosting a fabulous event. So, well, the event brings to a close now. Thank you.